All right, welcome back, fifth graders. This is Mr. Mace again with a very similar learning target to what the last video was. We again are going to be adding decimal numbers. So please make sure you have your math expressions book out, maybe some scratch paper, something to write with, so that you are prepared to kind of work through some of the problems that I'm going to put in front of you today. As you look at the board or your screen today, you can see that we have Activity 2 listed here, and we want to point out just a couple of things that might look a little unique or might be slightly different from what you are normally seeing here. So we've got 3 different example problems, all of which are set up correctly. Okay, they're all done correctly, but the thing I want you to identify and to notice is that we have, in each case, the decimal point lined up, and that is kind of the number one key, the number one factor in adding with decimals. Otherwise, it's just straight adding, right? The problem that I haven't drawn the arrows to here yet, we only see this one decimal point, is actually the same as the other two. Every number that you will ever write has a decimal point in it. Sometimes we choose not to write it. It's called an implied decimal because the number is a whole number. 8 is 8 wholes, or 8 in the ones place. I'll just write ones place right here. And every one of these numbers has a decimal point at the end of it. And it looks really weird to have the number set up like this, but that is going to be the type of problem that we are trying to solve today, making sure that we are adding the correct place values together as we move forward through this lesson. Sometimes it helps, fifth graders, if we actually add some zeros to the end of our problem just to make it look a little bit more visually appealing to what we are used to doing here. So instead of just leaving this an 8, maybe I want to add the 3 zeros. It doesn't change the value of the number. Adding a 0 to the end behind a decimal point does not change the value of the number in any way. And this maybe looks a little bit more logical to how I might solve it. So now it's just adding with those zeros, which again doesn't change my number. But we can see that this is essentially a mental math problem if we line the number up correctly. A lot of mistakes people tend to make in these situations would be to put the 8 there and then have our 0 to 7 and have these line up. But the problem with that is our decimal points then are in completely different locations, and we're adding an 8 in the ones place to a 7 in the thousandths place, which is what that ends up being. All right, so as we move forward here, you can see our buddy Puzzle Penguin here again has shown up quite a few times already this year. His question says, "Dear math students, I am ordering a book from a catalog. The price of the book is $15 and the tax is $0.15, or another way to say that would be 15 cents. Altogether then I will have to pay 15 plus 15 or $30 for this book. The tax makes the cost twice as much. This doesn't seem reasonable. Does it seem reasonable to you? Or have I made some kind of a mistake?" So again, guys, he's making the mistake that we just got done showing you on the last screen that talks about the fact that 15 with the decimal point at the end of it, $15, is not the same as 15 cents. So in all honesty, we are looking at two separate 15s here. They are not 15 plus 15. It'll actually be 15 plus 0 and 15 plus 0 if I add the zeros in the place values that are being represented by the numbers they show us. So keeping straight when a number is just a whole number, keeping straight where that decimal point, and for me, fifth grade students, I just get in the habit of writing that decimal point at the end of my whole numbers in this chapter, in this unit, for the simple fact that then it reminds me that I need to make sure that I line these things up. All right? So our response to Puzzle Penguin in that situation would be just to make sure that you are adding those place values together correctly. Now, if you look at the bottom section here, and this is on page 59, so at this point we are in our math expressions books, and hopefully you are following along with this. It asks us to add, but it also tells us to try and solve it mentally. Now, I've said to my class multiple times that I'm never going to require you to do something mentally. If you feel more comfortable writing things down and jotting it down, that's great, and I would get in the habit of doing that because there's not going to be a lot of math problems where we expect you to do it mentally. So if they're asking you to do it mentally, it probably means that it's a really simple problem once we establish what the rule is or what we're trying to do here. So for problem number 2, the key is to identify what we're actually looking at here in terms of labels or symbols. If we look at this first number here, we see that that has a dollar sign. So that's representing $28. And if I write that out, that's going to be a 28 with a decimal point behind the 28, because this is how I would represent $28. Okay? This symbol says 32 cents. Now, they both look like whole numbers, in all honesty, but the symbol determines where that decimal point is going to be. And we would write 38 cents, or 32 cents, excuse me, with a decimal behind the decimal point. So this would be the representation that I would see if I'm writing 32 cents, which is what that symbol is telling me to do. And this then becomes simply copying the numbers down with the decimal point in the middle of it. So it is mental math, because anything plus a 0 doesn't change the number. So I'm actually adding the $28 to the 32 cents. I'm just combining those two numbers and putting a dollar sign in front of it, obviously, because we're dealing with money. Putting a decimal point, though, between those two numbers. So the dollar sign tells us the decimal point is behind the 28. The cents symbol tells us that the decimal point is in front of the 32. All right? So if we look at question 3, same thing here now. Now it's a little bit easier to determine the decimal point on this first number, but this is $42.05. And this cents symbol tells us that that should actually be represented as decimal point 63. So the majority of this problem, we are simply going to be adding with zeros, but in this case we do have to change the 5 to an 8, because 5 plus 3 is 8. 6 plus 0 is 6. 42, or 2 plus 0 is 2. 4 plus 0 is 4. And then we put the dollar sign in front of it. So again, a little bit more work involved, but still relatively mental math scenarios. So guys, I'm not going to go through all the problems on here, but I would definitely practice them, especially if you are looking at this and aren't still quite sure of how this is supposed to look. But there's plenty of example problems there. And if you have questions with your teacher, please make sure you're contacting them about that. The number one key to adding or subtracting, for that matter, with a decimal is to make sure that that decimal point is lined up and the place values then are being added to the correct place values. It does us no good. I'll do one more problem here, and that's number 10. All right, we'll jump down to the bottom here. If I am going to represent 6 meters, and the reason I'm writing this one down is that the problem when I actually write it down is going to look really, really weird based on our normal, like how we would typically write an addition or a subtraction problem, because it's so shifted one way or the other. I'm representing 6 meters as 6 decimal point. Okay, because the decimal point is implied. It doesn't show us a decimal point, which means the decimal point always comes at the end of that number. All right, now if I represent the second number here, that does show me a decimal point. I'm going to make sure that I put it right under my existing decimal point, and I'm going to line the 0 up underneath that 6, and then I'm going to make sure that I've got my 3 place values after the decimal point. So again, not a hard problem once we set it up correctly. But the key is to make sure that these decimal points are in line so that our place values. This is 6 in the ones place plus a 0 in the ones place. This is a 7 in the thousands place plus a 0 in the thousands place. And again, if it helps us to write those extra zeros in there just to give us an easier visual to deal with, I'm perfectly fine with that. Remember, the decimal point moves straight down into our answer when we are adding with and subtracting with decimals. So our answer for that one should be 6 and 7/100ths, or 6.007. All right? Nothing too challenging with that. And again, I'm hoping that you are all fairly comfortable with your adding and subtracting. So as we look at these problems on the next page, so page 60 in your math expressions books, 5th graders, one thing I do want to state about these problems is the book does a really good job of lining up your decimal points for you. So I'm not, again, going to go through a ton of these problems just because I think you guys need to practice and do this on your own. But notice that in those first 4 problems, they have lined up the decimal point for you. All right? And the key here is this middle row, 16 through 19. And those problems are written what we call horizontally or across the page, and this is where our problem might arise, or this is where we might start making, in my opinion, more silly mistakes in our math, because we now are in charge of lining up those decimal points. We are in charge of making sure those place values are in the correct spots. So as I look at problem number 16 here, guys, I think there's a lot of students out there who would look at this problem and write it down like this. Okay, but that is the incorrect way, and hopefully you see that these decimal points are not in line, all right, that I need to shift that number over. Let me erase it here and write it correctly now. And it's, we said, the hardest part about this is probably going to be the fact that the problem, when you do write it down, is going to look a little weird compared to what we are used to doing. The key, though, again, is to make sure that that decimal point is in line. So now I'm adding my 5/10 to my 7/10. Okay, and again, if it helps me to add zeros to the other numbers just to make sure that they are consistent, that's fine with me. I have no problem with that. In fact, it sometimes makes it much easier to solve the problem. So then we just go through with regular addition. 3 plus 0 is 3. 7 plus 5 is 12. Two-digit number, right? So we need to regroup, bring that new group of 1. And that does not matter if it travels over the decimal point. That's the other thing that sometimes people make a mistake on, is they see, well, this is behind the decimal. I can't bring that carried number in front of the decimal. Nope, that's not accurate. You can, this is base 10 number system all the way through here, guys. So it does not matter if my number's on the back side of the decimal or the front side. It's always 10 more than the place value behind it. So once I regroup that 1, it becomes 9 plus 1 gets me to 10. So my answer for this one is 10.23, or 10 and 23 hundredths. All right, so hopefully that makes sense to you. All right, one last problem here, and then you'll get an opportunity to practice this skill on both an exit ticket, or if you want to do some adding problems here as we are moving forward with the lesson. If you want to do the ones that we haven't solved in the book together as good practice, I would highly recommend doing that. So if we look at number 17 here, same type of situation. I've got 605.4 or 605 and 4/10. But the next one, I see that I've got 89 hundredths. Okay, everything is behind the decimal point. So if I line up the 4 with the 9, I'm definitely going to be adding two numbers that are in different place values. That does not make sense for me to do that. So I want to make sure that I put my decimal point first, and then I copy down the number in the correct place value. I'm actually going to be adding the 8 to the 4, not the 9 to the 4. And the 9 is going to be hanging out here all by itself. So again, if I don't feel comfortable looking at it like this, or it seems odd or weird, add some zeros to match up those place values just to make it easier. If I add the zeros to the outsides of these numbers, it does not change the value of those numbers. All right, so 0 plus 9 is 9. Here again, we have that same situation on this problem as we did in the last one. 8 plus 4 gets me a two-digit number. The 2 goes down and the 1 gets regrouped, even though it is over the decimal point. Okay, even though we go over this decimal point, it's still 10 more than, the 1's place is 10 more than the 10th's place. All right, 5 plus 1 is 6. 0 plus 0 is 0. 6 plus 0 is 6. Again, decimal point straight down into my answer when I'm done with that. And my answer for number 17 is 606.29. All right, I'm going to pause the video here just for a second. I would like you to try to solve problems 18 and 19 here, and then on your own, and we'll check those quick, and then you can go and start the exit ticket.